Hello everyone. In this video, I'm going to be solving some questions, some MCQs on plucked string, open pipe, and closed pipe under sound waves. Okay, so follow me through as I respond to this. Now, the first one says a string fixed at both ends vibrates in its fundamental notes. The wavelength is equal to. I want you to note this. This is actually fundamental note. Okay. The fundamental note of a string is this. Yeah. And this is, you have a node here, you have a node here. The distance between two nodes is lambda over 2. That means 2 wavelengths. So that means the length of the string in its fundamental notes is lambda over 2. That means lambda is going to be equal to 2L when you cross multiply. So the answer to this question is B. Now the second question here says the frequency of a vibrating string depends on all except the frequency of a vibrating string depends on all except. Now the formula for frequency is the frequency of a vibrating string is 1 over 2L then root T over mass per unit length. L here stands for length, T is the tension, mu here stands for mass per unit length. So the only one outside is this. So D is the answer to this question. Okay. Now the third one, it says in a plucked string, increasing tension will, the answer is that it is going to increase the frequency B. That's because frequency is proportional to the square root of the tension. Okay, very interesting. Now the fourth one is the fundamental frequency of a string of length L is given as the fundamental frequency of a string of length L. The answer is that the fundamental frequency is equal to V over 2L. Okay, so this is V over 2L. I already mentioned that earlier. This is the drawing for the fundamental frequency of a string. So a loop is lambda over 2. So you can say the length is lambda over 2, which means that lambda is equal to 2L. Okay, so you can go ahead and say that velocity or frequency is supposed to be velocity over wavelength, and wavelength here is 2L for the fundamental frequency, and so you have V over 2L, so B. Now number 5 question here says the speed of a wave on a string depends on tension and mass per unit length. Not this, but tension, mass per unit length. That's because the speed on a spring is actually equal to the square root of tension over mass per unit length. So the speed in a string depends on only tension and mass per unit length. So A is the answer to that question. Now for number 6, in an open pipe, the fundamental frequency has a wavelength. Now this is an open pipe, okay? And well, even though that's a very straightforward question, because the wavelength of a fundamental frequency, let me show you how that is. The fundamental frequency of an open pipe looks like this. It starts with an antinode, end with an antinode. The same thing here, starts with an antinode, end with an antinode. Now this part of the antinode is lambda over 4. That means a complete loop is lambda over 2. So half of it is lambda over 4. This is also lambda over 4. So, and this is the length of the pipe. This is an open pipe. An open pipe is open at both ends. So the length is going to be lambda over 4 plus lambda over 4. And that will give us 2 lambda over 4, which is equal to lambda over 2. So if L is lambda over 2, that means lambda is going to be equal to 2L. So the answer to this question is A. Okay, that leads us to number 7. It says in an open pipe supports odd harmonics, only even harmonics, all harmonics, no harmonics. Okay, the overtone of an open pipe, that's Fn, is actually the same thing with the overtone of a string. It is n plus 1 times F naught. Okay, n plus 1 times F naught. Okay, where F naught is the fundamental frequency. Okay, so if I want to find F1, it's going to be 1 plus 1 times F naught. That means 2 F naught. Now what you will notice is that the fundamental frequency F naught, the first overtone is 2 F naught. If I put n to be 2, it will be 2 plus 1. That will give us 3 F naught. N to be 3, 3 plus 1, 4 F naught, and so on and so forth. So not odd numbers, not even numbers, but all harmonics. So C is the answer to this question. Okay, now the first overtone in an open pipe is, the answer is, remember okay, the overtone, the formula for overtone of an open pipe is n plus 1 times the fundamental frequency. So the first overtone is F1, that means n is 1. I'm going to put this 1 plus 1 times F naught. So 1 plus 1 is 2, 2 times F naught. So that's it. 2 F naught means the second harmonic. Okay, so 3 F naught means third harmonic, 4 F naught means fourth harmonic, and so on. So B is the answer to this. Okay, then in a closed pipe, number 9, in a closed pipe, the fundamental wavelength is, this is what the closed pipe looks like. It is closed at one end and open at one end. A closed pipe starts with an antinode and ends with a node, like this and like this. And this is half a loop. A complete loop is lambda over 2. So half a loop is lambda over 4. And here is the length of the pipe. So L is going to be equal to lambda over 4. That means lambda is going to be equal to 4L. So that's the answer, 4L. Now, number 10. A closed pipe supports all harmonics, only odd harmonics, only even harmonics, no harmonics. Now, the frequency of overtone of a closed pipe has a formula 2n plus 1 times the fundamental frequency. So the first overtone would be 2 times 1 plus 1. Okay, fundamental frequency. 2 times 1 is 2 plus 1, 3. So 3 times the fundamental frequency. F2 is 2 times 2 plus 1 fundamental frequency. That's going to be 5 fundamental frequency. And F3 is going to be 2 times 3 plus 1 F naught. And that's going to give us 2 times 3 is 6, 6 plus 1, 7 F naught. So you notice that the fundamental frequency is F naught. The first overtone is 3 F naught. Second overtone 5 F naught. Third overtone 7. Okay, fourth overtone 7 F naught, and so on and so forth. These are only odd numbers. So you have only odd harmonics. Okay. Now number 11. The first overtone in a closed pipe is, the first overtone in a closed pipe is, in a closed pipe, the first overtone in a closed pipe is 2n plus 1 times F naught. So the first overtone is F1. That is 2 times 1 plus 1 F naught. And 2 times 1 is 2. 2 plus 1 is 3. So that is 3 times the fundamental frequency. So that is the third harmonic. 3 times the fundamental frequency means the third harmonic. So the answer to this question is B. Interesting. So here we say the frequency of a wave is 200 Hertz and wavelength is 0.5 meters. The speed is, the frequency of a wave is 200 Hertz, wavelength is 0.5. So I can write out the parameters. This is 200 hertz, and the wavelength is 0.5 meters. Now speed is simply frequency times wavelength. That's the formula. Frequency is 200, wavelength is 0.5. That would give us 100 meter per second. So A is the answer to that question. Number 13 says, if the length of a string is doubled, its fundamental frequency becomes. If the length of a string is doubled, its fundamental frequency becomes A, doubled, B, halved, C, quadrupled, D, unchanged. Now, the relationship between fundamental frequency and length is that fundamental frequency is inversely proportional to length. Inversely proportional means that if the length is doubled, fundamental frequency will be halved. If the length is tripled, fundamental frequency will reduce by 1/3. If the length is quadrupled, fundamental frequency will be reduced by 1/4, and so on and so forth. So because it is inverse related, so the answer to this question is that it is going to be halved. Okay, so then the next one here, if the tension in a string is increased 4 times, the frequency becomes. If the tension in a string is increased 4 times, the frequency becomes. The relationship between frequency and the tension of a string is that frequency is proportional to the square root of tension. Okay, so whatever this is increased, this will increase by the square root of the same factor. So for example, in this question here, the tension is increased 4 times. So if this tension is increased 4 times, so I'm going to have 40 square root of 4. Square root of 4 is 2. That means the frequency will increase 2 times. It is directly proportional, meaning as one increases, the other one increases, but the square root sign means that they will not increase at the same rate. While this increased by 4, this will increase by square root of 4, which is 2. So the answer is twice, A. Okay, thank you very much. Thank you.